Hello everyone, and welcome to this third and final video in this summer series. This one in particular is about securing container deployments with open source tools. My name is Josh Duffney, and I am joined by Paul. We're both cloud native advocates here at Microsoft. And we're going to do this session a little bit different. There isn't going to be any PowerPoint, so you can thank me in advance for that one or whatnot. But we're going to do it live. It's going to be a little bit more fun and a little bit more loose. But before we dive into that, I kind of want to set the stage for why we should kind of consider all these things. There's going to be a lot that's covered in this 90 minutes. We might not be able to get through every single thing that I have in this repository, and that's totally fine. But there's a really good talk by Kelsey Hightower. Most of his talks are really good, but this one in particular fits the needs of this course or this live stream. And it was around the secure supply chain, which should be no surprise. We're talking about securing container deployments on AKS in this live stream. But I really liked how he opened up the talk, where he kind of explained the situation where he's this developer and he's got his laptop and he's in a coffee shop, and he finds this USB key, and he's like, oh, what's this USB key? And he plugs it into the laptop, and lo and behold, it has the exact code that he had gone to that coffee shop to write, which was this little router that was written in Go, and he could just plug it into his code base and not have to use the standard library and go for it. And everybody kind of immediately has a gut check for that's not what you should do. You shouldn't just plug in thumb drives. But then he poses the question, which was, is it that different to plug in a thumb drive that you found at a coffee shop than it is to clone a repository from GitHub that's in the public, that's a public repo? And he kind of convinces you that there isn't too much of a difference. And so the tools that we'll talk about inside in this 90 minutes are going to be related to how we can have better security around using tools that we kind of acquire from the internet, specifically open source tools. And the beauty of it is these tools in themselves are open source. I don't know, Paul, do you want to add anything to that?
No, all I would say is I would never plug in a random USB into my machine.
But yeah, so many times I've seen developers where they're like, they're pulling straight from, and this is myself included, so I'm not singling anybody out, but they're pulling their images straight from, Docker Hub,
mm-hmm.
In their container, and they're deploying it to production. There's not even a container registry inside, and so there's not much. In your eyes, is there any difference? Does that spark anything for you?
I mean, it just feels like, oh, it's on Docker Hub. Everything should be safe, right? But then you don't really pay attention to who's actually publishing these packages. So I guess that could be along the same lines as just picking up a random USB. Yeah.
Might be a little bit different if it's trusted publisher. Maybe you're inside of a headquarters, you're inside Microsoft's headquarters. And you find USB. It might be a little bit more trusted to be inside there because there's some badges and stuff. And so if it's underneath maybe one of their organizations, something might be a little bit more trusted.
Right.
But yeah, with that, what we'll do is we'll switch over and we'll just start diving in.
Cool. No slides. I love that.
No slides. So there's a GitHub repository here that we're going to walk through and everything. So to start, though, we will take a look at one image. So all the 5 slides that I'm sparing you from can kind of be distilled in this image. So what we will do in this 90 minutes is we'll set up this workflow. And this workflow consists of 2 parts. There's a build and then there's a deploy. And here's where we introduce these open source tools that I mentioned that allow you to secure your container deployments. And in this instance, we're worried about deploying them to AKS or Azure Kubernetes Service. And the reason for that is there's some of the tools in here that require that platform to work. But I would imagine there will be in the future tools that will work in different places, like we talked about in week 1, where we deployed our applications to container apps or Azure Container Apps.
Yeah.
ACA.
Yeah. I've heard of, I've seen Trivy. I've used Trivy a few times, so I'm somewhat familiar with that. I know Notary is a thing that you like to work on a lot, Josh, but what's that copacetic thing?
So copacetic is another open source tool. Is actually created by the Azure upstream team inside Microsoft. And what it allows you to do is automatic patching. So just to go back one layer, to give you a full end-to-end of what we're going to work through here, is we're going to talk about first, we'll obviously have to build a container image. And we have this image that we pulled down. Either we built it ourselves, but even if we built it ourselves, we're depending on some base image from somewhere. So we're still depending on something. We're unlikely to start our container images from scratch. And so because of that, there's this awesome tool called Trivy. And Trivy is a vulnerability and configuration scanner. For the purposes of this demo, we'll be using it for a vulnerability scanner. And what that does is it goes out and it scans your container images against a known CVE repository and brings back a list of the known vulnerabilities that your container image has. And what's really cool about that is it can output a JSON file that then copacetic can take and patch automatically for you. And so it alleviates the burden of trying to figure out what version or what tag of the image you should go to remediate these vulnerabilities, or opening up the container images themselves and patching them and creating your own version of it. Copacetic automates that part by opening up, taking that file, and the little caveat, it only addresses OS vulnerabilities at this point. But anyway, it will take that patch file and then add another layer to your container where it's gone through and patched all of them for you. We'll see that in action later on. And so that builds trust. You know, we've got our container image, we've pulled down the base image, we've built it, we've scanned it, we found some things that weren't so great, we've patched it, and now we need some kind of a mechanism to say, I trust this thing. You know, I've done the necessary work to make sure that it's as secure as possible. And that's where Notary comes into play. Now, the tool that is going to be used is notation. It's the CLI. Notary project, and to be specific, is the name of the organization on GitHub, or the CNCF organization that maintains that tool and develops that tool. So Notary's project, and notation is the CLI we'll be using. But what that does is it puts a digital signature on the artifact, typically inside of your container registry. And that's how you can essentially validate that there's been some the integrity and the authenticity of a particular image. And it signs it at a digest level. And we'll go into the reasons why in the demo, where you want to sign the digest and not the tag. But anyway, then you can kind of sign off. We've now got an image up in a repository somewhere that we trust. And so now comes the deploy part. I really like the analogy, without this last step here. The signing is kind of like the people at Costco that just kind of swipe with a highlighter your receipt, saying that you paid for it. They don't really look at the receipt. And so if you don't have any kind of governance on the back end to enforce these policies, or emission control is the term for it, then they have less value. But luckily, there are some tools, namely Ratify and Gatekeeper, or Open Policy Agent, that let us have some kind of admission control on our cluster. So this is the piece that is specific to Kubernetes, that are deployed with Helm charts, as you'll see in a little bit, to the cluster. And what they do is they check the images being deployed to a namespace and try to validate them. So if they can validate that certificate, they let the containers deploy to the cluster. And if that image is not signed and it's being pulled from some kind of a different source, it rejects it. It rejects it. So that way we have some kind of control on the back end to make sure that we're only running safe images inside of our environments. So that's kind of the full end to end.
Cool.
Yeah. So this repository here is meant to be walk through like a workshop, and everything in here has been automated from the development environment up to the infrastructure that you need. The infrastructure is a little complex. If we wanted to take a look at that, we can, if you want to follow along with the steps in documentation, After the fact, there is this directory called docs. And in here, there's the workshop MD. So this has all the steps. But what I want to do just quickly is show you kind of what the architecture looks like a little bit. And I believe it's this Ratify on Azure and this image here. So this is the infrastructure roughly that I've automated with Terraform to build out. So there's going to be a Key Vault instance that we build. There will be a container registry. And there will also be a workload identity that's used by the cluster, the AKS cluster, to get the certificate to validate the signature. And then there will, of course, be Azure Kubernetes service deployed. So this kind of gives you an idea of what the Azure resources that are going to be deployed momentarily coming up. So let's go back and start from scratch. So I've removed this repository from my local computer. So I'm going to click code, local, and I'm just going to copy the HTTPS link there and open up terminal. So this might be a little difficult to see, so let me minimize that. But I'll switch to code in just a second. So where am I? Let's change to my GitHub folder. You can see that I don't have this repo, so I'll clone it. And now I'm going to CD into that secure supply chain on AKS. And I'll just do code dot to open VS Code in this directory. And it should prompt me, and if not, yeah, there we go. So I've set up a dev container in this repository. And the reason for that is some of these tools, mainly Copacetic, they only work on Linux right now. There's only a binary for that particular OS. And so I'm using a dev container for that reason, but then it also allows me to install the tools for you. I didn't want to have a big set of instructions like, here's how you get the notation binary, and here's how you put the plugin. If you're curious how that all works, there is inside scripts. There it is, this install DevTools. And so all the things that are in here and everything that's going on is in here. And we can dive in that if there's any questions. But for now, what I want to do is, now that I've got the repository clone, I want to open it in the container. So it's not my local instance. It's inside the container that I've built.
Yeah. And I was using the dev container in last week's session as well, but in a different way. With these dev containers, you can use them two different ways. If you have Docker Desktop installed on your machine, you can literally open the dev container using Docker Desktop. What I like to do often is sometimes I don't like to run Docker Desktop on my machine. Sometimes I want to run my container in the cloud. And so you can literally open that dev container, which is the same exact configuration, regardless of whether you're in the cloud or on your Docker Desktop. But you can actually open the dev container in a GitHub code space. So
absolutely. Yeah, if you don't want Docker installed locally, for sure.
I mean, like, if you don't want to install yet another tool on your machine,
Mm-hmm.
Yeah, and CodeSpace is pretty easy to get started with. You just need a GitHub account, and I believe, don't quote me on this, but you get like X amount of hours for free. I thought
at a certain size,
yeah, at a certain size, yeah. So, great way to get started.
Yeah, good plug for CodeSpaces there.
Yeah, and I mean, for me, if you find an open source repo that doesn't have a dev container, that's probably one of the easiest PRs you can submit into the open source.
Oh, absolutely.
Repo.
If you don't have, So if I didn't have a dev container, this 90 minutes would be eaten up just setting up the dev environment. On it for real, it would be. Let's see here. The first thing that I want to do, I've got to deploy the infrastructure. So I'm going to log into the Azure CLI. And it's just going to authenticate to my subscription. Fingers crossed. Oh, it worked. I don't have to do any troubleshooting there. So let's see here. AZ account. See here. Show. Probably log me into it logged me in the right one. Awesome. Okay, so I'm in my test subscription.
Yeah. Oftentimes I get put into the wrong subscription.
Oh, I get in a random one.
Yeah.
Wish you could change the default there. So I've got the AZ CLI logged in, and I'm using that as a way to authenticate to Azure so I can run my Terraform stuff. Now, all of this that I'm running through here is in a script and a document. So the script is setup sh, and under docs, there's also a mirroring setup. So I will run through the script portion just because it's got the commands, it's easier to read. But if you wanted to see, the tutorial version of it, then it would just you would do the MD file. So what I need to do is change into the Terraform directory, and I'm going to do an init and auto approve. That's going to deploy it.
Okay.
And this will take.
Sorry, Josh. Which MD file should users be following?
Oh, good call out. So this is for setting up the environment. It's the very first thing. It's just setup MD.
Okay.
Right here.
Got it. Oh, I get it now.
Yeah.
Setup.sh, setup.md.
Yeah. So there's a markdown file for everything, and then there's the script for everything that I have here.
I gotcha. Okay. Yeah. Cool.
So I think that should be doing the apply now. Awesome. And if you just jump to if you were just looking at the workshop that I mentioned previously, let me close all these tabs here. There, it lays it out too. So in here, it'll actually call out that you need to follow the setup. So
got it. Cool. So what's going on here? I see Terraform flying by.
Terraform is building it all out. So what we can do while that's building is just take a look at the main. It's somewhat of a complicated setup, but then again, Paul, like once you've automated it, there we go.
Yeah.
It's not too bad. It's just the hacking that is involved to get it to that state. So if we look at Terraform main, and I just Terraform is just a preference. A lot of people are like, why didn't you use Bicep, or why didn't you use ARM, or whatever it might be? It's just a preference. I'm more comfortable with Terraform. I've used it for a long time. And it's declarative. I like that. But anyway, we're obviously connecting to Azure. I'm using this Azure AD to read in the credentials of the AZ login, so the token that the Azure CLI has. I'm sharing that with Terraform, so I don't have to create using the environment variables to authenticate. And then setting that data there. So I'm creating a resource group, first of all, and how it's getting this information, if we look at this, is it's pulling them all in from the TFRs. So if you were to follow along, you're probably going to have to change the things that need to be unique. I think key vault and the container registry name will have to be changed because those have to be globally unique across all of Azure. But this is where all the variables are coming in. So if you see this var.resource group name, it's coming in from here. If you're not familiar or too familiar with Terraform. But then we're also inside of that resource group creating a registry. So this is the container registry that's going to hold all of our images that AKS is going to talk to. And there's a nice little, this is why I leave comments in my code, remind me of things. So I have an anonymous poll, which is not a best practice, but it is a temporary limitation of copacetic, which is interesting. There's interesting backstory to copacetic, where it was originally designed to work against the internal Microsoft repositories. And so an interesting little quirk about it right now is that it only patches images that are already on a remote registry. It won't patch them locally yet. And that was just because the need for the tool at the time was only to patch images that were already on a registry. But if you plug this tool into your local development workflow, it makes more sense to patch it locally and push once. And so that's something that'll probably be in the works soon. But
so this was like an internal. This was an internal tool.
Internal tool. Yep.
Okay. Cool.
Yeah, I saw the automatic patching.
Sharing is caring, right?
Yeah, sharing is caring. So we've got the container registry. Not too fancy with that. It's a standard one. I believe notation requires that for. That should have been another comment. I'll have to go back and add that in why it needs to be standard. But I'm pretty sure it's tied to notation somehow. And the cert, I believe it doesn't allow signatures unless it's standard. But I'd have to double check that. And then we're going to create a user-assigned identity. And this will be the workload identity that AKS uses to reach the certificates. And then it needs a role of ACR pull. So it needs the ability to pull images. So that identity that AKS is using needs to have some way to connect to the ACR instance and have the rights. And so the role ACR pull is all that it needs for that, to obtain the images. To validate, it needs a different set of permissions, which are later. And then there is a key vault instance, of course, that has the certificate. So that is used by notation and ratify. So notation uses that certificate to sign, and the way that that's created needs to be specific. It's down below. And then ratify accesses that certificate secret, to be precise, to validate the signature.
Got it.
Yep. And so I'm giving myself, because it annoys me when I create something that I can't access it. So I'm using this to create an access policy for my logged in user to be able to access the thing, which with Terraform gets funny anyway, because whatever you're running it as isn't actually you. It's just a version of you that has a different service principal ID. Long story anyway. So yeah, that's the key vault. It looks like we're already done here. But then there's
pretty fast.
Yeah, not too bad. I think it takes roughly 6 or 7 minutes. So I've been talking a lot. The other access policy is for the workload identity, and this is kind of a trip up in the last 2 releases of Ratify. So previously it needed certificate permissions, and this has to do with the internal libraries that Ratify is using, the SDK for Azure. And if you didn't know this, when you create a certificate in Azure, there's actually a secret underneath of it that is used to access it. So the previous library used the certificate permissions, but after version 1007 or RC7 release, they're switching it to secret permissions. So I have both, just to cover both scenarios in this demo. But moving forward, it'll be secret permissions. And that's the access policy that the identity that Ratify is using needs to be able to validate signatures on your cluster.
So this is a way for Ratify to go grab that.
Yeah. Yep.
Yeah.
And that's probably the tricky. We should probably do a whole nother 90 minutes on just workload identity at some point.
Yeah. I just talked about workload identity this morning, and I mean, for the folks watching at home, workload identity is basically just a non-human service account, right? So I mean, we've had non-human accounts for decades in the data center, so this is just the cloud equivalent of that. So.
Oh man, it brings me back to my Active Directory days, where I tried. That was one of my big things, big accomplishments as a systems engineer, was getting people off their shared user passwords and user accounts and service accounts back in the day in Active Directory. Oh, what were the servers? I think I was in charge of decommissioning the 2003 servers.
Okay.
So yeah, and upgrading the forest to 2008 R2. That was probably in, I don't know, 2011, 2012. So
hopefully it brings back good memories.
So my fondest memory of that time, while we're on it, was an Exchange admin. So in 2003, Active Directory, it was tied to Exchange. Mm-hmm. And so when you deleted the mailboxes, you deleted the users. And so this Exchange architect was cleaning up old domains after a company merger, thinking he was deleting their mailboxes, completely tombstoned an entire domain.
Oh boy.
So that means unrecoverable. People aren't too familiar with AD. And so with PowerShell, 3 of my coworkers and I were able to, we had this asset management database that had all the users. We had to recreate the entire domain using PowerShell. So,
when you look back, those are probably fun times.
It was.
When you're in the heat of the moment, though, maybe not.
Saturday and Sunday spent in an office cubicle. Not so much fun, but I don't know, I learned a lot. So, the last piece before we move on here to Terraform is just spinning up the cluster. The only thing to note really here is that there's this link here that's linking the ACR to AKS. That's the only thing really special about this node here. But everything has been created, and now I'm going to show you a little trick that I learned from Paul. So if we go back to the setup, is you can grab the variable output from Terraform and stuff it into variables. So let me just move that down a little bit, clear the screen. So I'm inside the Terraform directory, and I'm just going to export all this information because I need all of this for later on in the demo. I need to know what the key vault name is. And so instead of going to Azure and clicking a little copy button, you can define Terraform output and then use the Terraform output command to create variables. And in this case, I'm creating environment variables with export. But
yeah,
so I'm going to do that.
Pretty handy.
A group name, just sanity check here. Got that. And then I'll change back to the root directory and use that to log into ACR because I'll need to log into that. Copy too much. So at this point, we have all the Azure resources, but I still needed to configure the cluster with Gatekeeper and then Ratify. So I'll do that with Helm, but before I can, I have to get the credentials. So I'm going to go ahead and get all the credentials, hold down, so now I can talk to my cluster, and I'll add the repo for Gatekeeper and install it. And this again, this is a one-time thing. If you were, this is because I'm tearing down and rebuilding everything. And in the production environment, this would maybe be a ticket, hopefully not to your ops team, but some kind of automated process inside your infrastructure as code would be best. But or GitOps, there might even be some stuff coming up from our team about that in a couple weeks.
Yeah, absolutely.
So now I've got Gatekeeper installed. And this is if you look at the documentation, it's pretty basic install. The only thing here is that you need to enable external data, and that's how Ratify talks to Gatekeeper to do its policy enforcement.
Ah, okay.
And now I'll add the Ratify. And then...
How do you know what to plug in for all these parameters? It seems like a lot of parameter data going in.
A lot of trial and error. yeah. So a lot of these tools, Gatekeeper not so much. I believe that's a graduated project, but Ratify isn't even at its V1, and Notation just hit V1 15 days ago.
That's right. I did see that.
So building all this has been a lot of pain, trial and error, because they've been developing super fast and introducing breaking changes. So much, in fact, that just yesterday, while I was making sure everything worked, two things broke. One being this right here, they added a new flag, and then the way that certificates were created also changed that I had to do. So,
but being V1.0, that would signal stability, right? Like
yes, huge. It actually unlocks a whole bunch of stuff internally too with that project going V1, because now they can't just introduce breaking changes into the platform. So Notation is going to be a lot more stable, and Ratify is aimed to go V1 pretty soon as well. So yeah, it's a lot of the pain that I'm experiencing right now is just the hustle to get to V1. I think more than anything.
Yeah, that's cool. Yeah, V1. That means basically it's like production ready. I was just thinking back, like how long it took Terraform to go V1, even though everybody's using it in production.
So I'm going to copy it from the MD here because I've got some extra takes here. When I was troubleshooting, I was going to roll back to 0.6, which didn't have an issue. That worked just fine last week. And then this is just a feature flag for 7+, but that'll be removed in the next PR that I do. So with all the changes though, to mention it, if you star this repository, the secure supply chain on AKS, I'm actively developing this all the time. So I'll probably run into it So if you run into issues, just check out this repositories, the code base and stuff, and then you should be good shape.
Cool.
So now that I've added that, I'm going to install Ratify. And if we just look at some of these arguments, I don't know, let's see if I can make it not highlighted. We're going to install it to the Gatekeeper namespace. So it's important that you put it in the same namespace as Gatekeeper. And that's the default namespace for Gatekeeper to install to. The certificate config needs to be true. This is a certificate.
One question on that.
Yeah.
I noticed it's prefixed with AKV. Does that mean Azure Key Vault?
Yes.
Because I use that. Oh, okay. Okay.
Yep. So it's that's a logic to tell it your certificate lives in Key Vault. And so that there's a bunch of logic behind that to go and query.
Got it.
This
Okay.
rotation flag, it'll just basically create a certificate for Ratify itself for you. You could bring your own certificate, plug that in there too. And then this is giving you all the information of the Key Vault instance itself. So what's the URI? What's the cert name that I should be using to validate my signatures? What's the tenant ID? And how am I supposed to authenticate? And that's where that workload identity comes into play.
I see. Yeah.
Yep. And so then what's the client ID of that workload identity? And all that should be populated by the Terraform we just deployed.
Got it. Cool. Does it work with other like secret providers or secret vaults or anything like that, or just Azure Key Vault?
Oh, good question.
Like HashiCorp Vault or
there is work being. I don't know if it's finished, but there is an open PR out there for HashiCorp in particular.
Yeah.
But I don't know. I think ORAS would be another. Well, that wouldn't be a secret repository. I'm not sure.
Obviously I'm a little biased. I would use Azure Key Vault myself. I'll just just wondering, like, if do I have any other options?
It is an open source project, so there are a number of people working from AWS and other bigger companies that are working to integrate it into that, because it's not just specific to Azure. For our purposes here, of course, I'm going to use Azure.
Yeah.
Let's see here.
I would too.
So now I think there's one final thing to do to set up, and that's to deploy the constraints. So right now we just have it on the cluster, but there's nothing telling it what's allowed and what's not allowed. And I'm just going to run these now just to deploy them. But there's a template, which I believe, well, correct me if I'm not, I can open it right now, actually, so you can see it. Is it a CRD? I'm trying to remember the terminology. Template.
It's a constraint template.
Yeah.
Yeah, that would be.
Isn't that a custom resource definition?
It is. It
probably would in Kubernetes terms.
Yeah.
Okay. That's what
which they call constraint template. So yeah.
And then there's the actual constraint of Ratify, which if we just take a quick look here, it's super simple. After it's got the CRD deployed, it's saying in all the resource groups, anything that has the kind of deployment, we want to make sure that there's a signature check. That's what the validation is. And then applied only to default namespace. So you can lock down certain namespaces if you want. If you have a dev one, maybe you don't want signature signing to be there, but in prod, probably do. So that's what actually prevents pods. And we'll see that later on where I go to deploy it and it gets rejected and says, you can't deploy to this namespace, this particular container image, etc. So now we have everything deployed, and now I can kind of go into a little bit of an autopilot. What I'm about to kick off is a demo script that will kind of prompt through most of the demo, and it's a line-by-line comparison of the workshop MD. So I think I'm at the repository, so I'm just going to run demo sh. Why is it doing that? No command R found. Oh, is it doing that fun? I bet it is.
Line feeds.
Is that what it's doing?
Uh,
Oh, I got to change utils too. Yep, because I deleted my repository and it pushed it up with Windows and put all the returns in there. What is this, the 5th time we've run into this lately? So
yeah.
I need to take up Steven's advice and change my Git settings. So here, I believe this is another. We want it to be LF, right?
Okay.
LF. Let's just run all this.
So what is it saying? Just use regular line feeds instead of a carriage return?
Instead of the carriage return. So let's. Now I'm in the Terraform repository. The account show. Just make sure I'm connected. All right. So now let's try. Just exit and create a new terminal. See, that was it. So just to recap, when I cloned it down, it had the Windows character return, which is the, was it C?
But what gave you the hint? What gave you the hint that it was
all that /R in there that was putting it out, and I know that the bash script is fine.
Yeah.
And so more familiarity with that problem than anything. But the /R in the output of the bash was the tell.
I gotcha. So if you ever see that, change your line feed settings of VS Code.
I'll drop a link in the chats of wherever this is for Steven's blog post. I don't know if you have that readily available that they can splash up there. But you can configure your Git client and VS Code to default to LF, and it will override no matter what. And so I ran into this because I deleted the repository and I cloned it back down. But when my last commit was, I pushed it from Windows and it changed the file format. So, but I think we ran into that debugging the ACA before, like again, the day before we go live, we find this.
I ran into it myself like 2 days ago or a day ago. Yeah.
All right.
It happens.
Well, here we are with the demo script. And so again, just to point you towards the doc that I'm following, it's the workshop MD. And this is going to be kind of a guided prompt through it. So this is a really great time if there's any questions about these different things. Again, to recap, we've deployed the Azure environment, the Azure resources. We've configured the AKS cluster. So all the hard work's out of the way. And now we can finally get to that graphic that I displayed at the beginning, where we're going to build an image and then we're going to scan it, patch it, sign it, etc. And so what I've done so far in this build script is I've got the environment variables, so I'm just pulling those from Terraform. What are my ACR instance names, etc. And then I'm building the images. So the source code that's in this repository is the infamous Azure voting app, rewritten in Rust by Paul. And Rust has a little bit of a compile time, build time. So this will take a few minutes.
A little bit, yeah.
But plenty of time to chat. So now I'm building that app. It's a 2-tier app where there's a web app to it and a database that's Postgres. And then it eventually will display. Well, I think they saw the app last week, didn't they? The voting app. You click and you deployed it to AKS. So
yeah. That's what we did last week.
Too much into it.
Yeah,
I'm using the same app in this demo.
We've seen it last week, and if you didn't see it last week, it's a good time to go back and check that recording.
Yeah.
Not now, but after we're done here.
And I'm also going to pull down the Postgres image. So I've built the Azure voting app, and that's just a Docker file here that we have the instructions for. So if you're curious how that app's built, there's a Docker file. And then I pull down the Postgres because I want to have that image as well. Because when I go to sign when I go to deploy the AKS cluster, I don't want to be pulling from Docker Hub. I want to have a copy of that image whether or not I did anything to it in my ACR, my container registry. Because your production environment might not even have internet access, public internet access.
That's true. Like you could have like a compliance policy that says, I don't pull images from even Docker Hub.
They might not even have the routes, only certain nodes in the cluster. That's how a lot of my prod environments that I had, my previous life as a site reliability engineer, dealt with. So yeah, I'm just listing out the images just to prove I only have the 2 images here. And now we'll go through kind of some of the variants and ways that we can use Trivy. So here you can see, and Paul, is the font size okay? Or should I go a little bigger?
It looks okay to me.
Okay, I'll just do one
That's better. Yeah.
So the command, again, these are all command line tools. Let me scroll up a little bit. A lot of it. Wow,
that's a lot of
vulnerabilities.
That's a lot of vulnerabilities there.
There's so much that the buffer ran out.
I see a lot of high, low, critical.
Well, let's just since that went faster and I was busy talking, we'll look at what it did. So right here was the first scan, and this is why we got so much. We're not filtering any of the results, but right here on line 27, I issued the Trivy image command, and then I'm giving it the name of the image with the tag. So I ran the Docker build command, and then I built this v0.1 alpha for the container image, and I haven't touched the base image of that container since you developed it however many months ago, probably 6 months ago or more.
It seems like a long time ago now.
And so now we're seeing all of these vulnerabilities. And so I'm not filtering them. This is all the known vulnerabilities that Trivy found in its database for that base image that you are using inside of the Azure voting app. So there's a lot there. We can filter it in several ways. One of them is by adjusting the severity. So maybe we don't care about all the low, or maybe we don't even care about high. We only care about critical. We can change that by adding this flag -- severity critical to the beginning of it. And now we can see that we have a total of 14 critical. And this will be cool because when we patch it, we'll be able to run the same command and see how much copacetic was able to do for us.
Nice.
So there's that. I mean, this gives you a bunch of information about the particular thing, links to it, and so forth. Another way that you can filter them is by the vulnerability type. And since copacetic can only deal with OS vulnerabilities, you'll definitely want to filter whatever the results that you're going to output by that particular type. Forgetting off the top of my head what the other types are. But so that's another way that you can filter it. And again, say, only give me critical OS vulnerabilities and give me a smaller subset. That's probably my biggest pet peeve with a lot of security tools coming from an operations role is something bad happens and security gets a ton of money. And what security does is plug in a bunch of scanners. And then they forward the results of those scanners to the ops team without any filters and contacts. And then in a healthy organization, there's just some good banter back and forth of, this is too much noise, we need to know what's actionable. And so this is just some way that we can start to make the things more actionable in our pipelines, is by using these filters.
Yeah.
So the other thing that you can do, this is just putting it out to the console, which is cool. It's good to know, but in an automated pipeline, that's not going to help you at all. So you can also output it by using the -- output and format. And then I'm telling it to exit with 0. So, don't throw me any errors, even if you error, kind of thing. Another way that you could use Trivy if you're not going to output a file is you can say, if you found anything wrong, throw an error. If you found a critical, throw an error, and then just stop the pipeline. Yeah.
Doesn't Trivy naturally exit with exit code 1 if it finds?
Yes. Yeah, by default.
I see. Yeah.
And that's because a lot of people are using. Oh, go ahead, Paul. Yeah.
I was just going to say, because when you do this later on down the line in a pipeline, because you're going to patch it, you don't really want to fail the whole thing.
Yeah,
right?
in my case, I don't want to fail it. But if you were just
Yeah.
using Trivy as like a break glass type thing, or not a break glass, but on-down core, I think that's the proper term. You know, like, oh, we found a critical, we're going to stop the pipeline and fix our base image and stuff. But with copacetic, hopefully it remediates enough for us. So yeah, I'm outputting it to patch.json, and that's what copacetic will use later on. You can also review it. So I'm just going to use some awesome jQuery here to pull out all the vulnerability IDs or package IDs for the vulnerabilities, and then sort by unique if there's any duplicates. So now, again, because I mentioned earlier, there's a limitation with copacetic where, I don't know if it's a limitation, it's just kind of how it works right now, where it can't patch this container image because it's local. It has to be inside of a remote repository for it to patch. And so I'm gonna tag the image with the ACR name, and then I'm gonna push it up to the registry.
So when it patches, does it patch it up there in ACR, or? That's
the fun part. It actually creates an image locally. And then you push it again, and that's where the double push comes in. And so it's suboptimal in this workflow to do that, because then you have another lingering. But it is a good audit trail, you know, to be able to do that. And you only sign the patch one, of course. But I would imagine that would change if this becomes a more popular use case for the tool, instead of being a tool that just runs against a registry and patches things that already exist. Because it's kind of it was developed in a way where the team that developed the tool was in charge of maintaining the registry and not necessarily individual apps and images that were coming through a pipeline.
Right.
Yeah. So now here comes the fun part where I'm going to patch, supposed to patch copacetic, but I think I waited too long. Because it requires build kit in the end, and it looks like it erred. So, debugging time.
Yeah.
So let's see here. Let's open up a side terminal and open up the demo. So what should have happened, and we might just be able to comment some stuff. It might have been too long for this background process. So it does rely on build kit. So that needs to be running in the background. And then you can run copacetic. Without build kit running, it will fail. So I have a feeling that's what it was. And so maybe I can just comment out some of the stuff that we've already done and try it again. Or I can run them manually, but how far along are we? We've got a couple steps. So I'll just try to comment some stuff out. So we've already got all the Trivy stuff. We don't need to do that. We've built, we'll probably need exports in there, and we don't need to tag and push anymore. So we'll just start right back up here. Oh, but I do need that variable name. So I'm creating a variable here that has the patched, or has the registry version of the tag.
And that's the original image name.
Original, right? Unpatched. Yep.
Got it. But yeah, because I noticed at the end of your patch version, you tacked on a -1.
Yeah, and so that, good call. We can talk about that just real quick. So the -1, whenever you patch, the practice that I've seen is that you append a -1. It doesn't break semantic versioning. It just appends a bit extra to it. And so that's one way you can still stay compliant with that scheme or standard. And then so if I were to patch this again, but I didn't change anything in the container, it could increment it to 2. But if I change the container itself, it would go to V2, and then it'd be -1 again, because it's a new image that's being patched. But a lot of times, you'll keep an app running out there for a long, long time, but you want to maintain it and patch it. And so you could increment the patch counter.
Got it.
All right. Well, let's see if that works. Again, I'm just commenting out stuff so we don't have to repeat the whole demo. So let's give that another try. load up the Terraform environment variables. And if this
And I
fails,
think you.
go ahead.
I think I saw a tweet from you about this demo scripting tool.
Oh, for sure, yeah.
Yeah, might want to share that with the crowd if they're interested in a tool like this in terms of like demoing scripts and things like that.
Oh, did it not? Build kit, no such file or directory. Interesting.
So you need build kit running?
It's saying that build kit isn't installed, but I guess I don't have a bin directory.
You don't have bin.
That's interesting. So I wonder if my dev container didn't build it. So if I go to scripts, install, it should have put build kit somewhere. So what if I just run this again? So it's airing like it can't find the build kit binary. So we'll see. But Trivy was there. And if we open up a new, does the patient exist?
I did notice in your install DevTools, you curl to download it, then you tar it.
Yeah.
And then where does it go from there?
It goes. Where does it go? Did I delete something? Let's see if that worked. If we go to the demo, we can just start. We can just see if this works.
Yeah.
In build kit. So now it's working. Let's kill that. And just see. Maybe it was just not there. So close that out. Clean up some stuff. Minimize that. And try the demo script again. And if that was the case, there must have been some kind of an error when I built the dev container where it didn't download that.
Yeah.
So typically what I do is I just rebuild the whole thing. What I do right now. But yeah.
That's what I did last week. There was something wrong with my
there's what you did.
Azure CLI and just rebuilt the dev container. Good thing is when it rebuilds, typically it'll rebuild it from cache. So any additional tooling, which in your case, you're running a script to install additional tooling, the image itself will be cached. So the image will be loaded pretty quickly, and then it'll layer on the tools. So it's nice and handy to have a throwaway dev environment.
I love that I can be working this for 3 weeks solid and never run into that. And then as soon as you hit a record button. But so here's what it's, not to get too sidetracked. So it was the build kit was missing for whatever reason. That binary didn't get moved to my bin directory. And so I installed it, and now I'm able to launch copacetic because it has a dependency on build kit. And I'm telling it to patch, and then I'm giving it the image. That's what the I means. And then I'm telling it to patch with a particular file, which is that patch.json. And then I'm tagging it something else. So I'm tagging it that -1 at the end. And that what it's going through and doing now, or just finished, is it grabbed all that, basically ran one big long apt-get install somewhere in here, and added a new layer to the image that patched everything that I found in the OS vulnerabilities.
I see.
So now we have this new patched image, and we can scan it. And I believe there were 14. See, this is when DevKit's supposed to exit. It was right here, but it was exiting before copacetic ran. But we moved from 14 vulnerabilities down to 1.
Nice.
And so just by shoving this in your pipeline, you'd reduce critical vulnerabilities. But
I was gonna say not awesome, not spectacular, but going down from 14 to 1, I guess that's better. So how come it left the 1?
It must not have been able to patch it. Maybe there isn't a patch release for that particular thing out there, and there isn't a new package that has that patch yet. Yeah, to go into that would have to be the specifics of all these packages, and has SQLite fixed this critical vulnerability, and is it not compatible with something else that we have in the operating system or in the container image?
Got it. So
yeah.
this is why the output JSON will enable you to kind of inspect this after the fact and make a decision on whether or not you want to move forward.
Yes. So you could also, I don't have SQLite, so I don't care about the vulnerability. So you could also throw
that's true.
an ignore in there. So Trivia has an ignore ability where you put a file and you can put what CVEs that you don't care about in there.
Yeah. I see. I got it.
So now I'm pushing the patched version, which it just added one layer. A bunch of layers existed and then one didn't, which was the patch layer.
Okay.
And we'll talk more about this digest here in a bit. And I'm also going to tag the Postgres and push it up too, because I'm going to need some version of that available for the cluster to run. So I'm not pulling from Docker Hub.
So when you patched the Azure voting app, can you do the same for like your Postgres container as well?
I could. Yep.
Huh. Okay.
Might be. You could add an issue to the repo if you want.
Yeah.
All right. Let's see here. So now I've got the patched version of the app that I care about in the registry, and I also have a version of the Postgres database container image in the container registry. Now we've gone through, we've signed it, we've patched it, or we've scanned it, we patched it, and now the thing to do would be to sign it. And this is where notation comes into play. It looks like the dev container was able to install notation because it didn't get an error when it ran this. So there's several different ways that you can use notation. You can use it locally. I'm actually using it with a plugin, the Azure Key Vault plugin, because the certificate I'm using is in Key Vault. So there's different plugins for different container or different secret vault providers or secrets providers that you have out there. And again, the option, you could always have a local certificate. You could even generate one on the fly and sign it with that, and then just keep a signature around. But I have it in Key Vault, and so I need to add this plugin to it. And then I need to add the key. So as part of the setup, I installed the notation CLI and then the Key Vault plugin. So you can look at that install script, install DevTools script to see how I did that. There are binaries for Windows and Mac for notation, just not copacetic. So notation will work on all the platforms. But now that it's installed, the very first thing I had to do is add the key, so that way it has the ability to access the certificates in there. And what you need for that to identify the key vault is the key ID. And so I grabbed the key ID using the Azure CLI command for that. And then I added it to notation. And so now the notation CLI is aware of that key vault key ID, and I am making it the default. So any signature that I add where I'm not specifying a particular key, it's going to use this one. That's what the marked as default is. And so I'm just going to list the keys so you can see that, and then it'll plop out the key ID there and with the the plugin name and so forth was. And now I need to get the digest. So this is a really good point. So if you're not familiar with signing, like I wasn't, several months ago, I've always addressed containers by their tag. And I kept getting a warning, and then it became an error when I was signing container images by their tag. And the reason why it was saying that, or the reason why it's a poor practice to sign tags, is because tags are mutable. They can change. So I can rebuild this app and push and override the V1, or is it 10 alpha or 01 alpha tag?
It was 01 alpha, I thought.
01 alpha. And my code can be completely different in that tag, but the tag's the same. And so if I'm signing a tag and it can change, then I don't have integrity and trust in that image. But if I pull out the digest, which is unique per layer, so every time I add a new layer to this, the digest is going to change. So if I were to update that tag, the digest will change, and then my signature is no longer valid for that newer version. And so it allows you to lock it. You can kind of think of it as like version pinning for your containers straight to a particular layer of that. And so you can get that by using the Docker image inspect command. And then there's this property in there called the repo digest that I'm getting that information from. And then it's outputted there. So that's what I'll actually use to sign. And it's also how I will update my Kubernetes manifest to deploy the application. So here, how I'll go ahead and sign. So the command for that is notation sign, and then I'm giving it the image. I'm not specifying a key because I set the default key, so it's using the key vault one, and I'm giving this big long digest SHA, and it successfully signed that. Now, if we wanted to take a look at this in the portal,
you might want to bump this up a little bit. Yeah, there we go.
How's that? Better?
Yeah. Yeah. Oh, yeah.
All right. So we'll go into the registry, and this was a cool thing that I learned as well. So if we come into the repository, it was funny, we were on a call and I was like, what is this new thing? And we're like, I think we know what it means. And I spent about 90 minutes reading. But if we go to the image, so I'm under the Azure Voting App Rust repository. And then inside there, we have our patched image tag. And if we go to refers, we're going to see that there is this CNCF notary signature. And so here's the signature artifact that's referring to this image. And we've signed the digest. And you can click on that and see some metadata about it. But what's interesting, if we go back here, there's now this new artifact, which I believe is a container, or it's a image index. And this image index holds the refer information to the signature, or to the image. The reason this exists is because in version 1005, or RC5, so the release candidate 5 before V1 came out, they started to use the refer API from the OCI spec, distribution spec. And that's an API that allows you to look up the relationships between layers and manifests. And without the ability to access that API, because it's experimental, there needs to be some way to grab the refer information, a fallback. And that's actually what this image index is a fallback that references that signature, that links it to the image. And so it's a way to have some kind of a trail and link between the refers of the image. And so, yeah, when I was building out this lab a couple of weeks ago, I was like, oh, that's new. What is that? So I started asking around, and, 90 minutes later and a bunch of trying to wrap my mind around the OCI spec, kind of stumbled upon that. So that's just a little information that you now have, that I have, around what this particular thing is that's created when you sign your images in your registry. Yeah,
no, that's all good to know, because I like to know where things come from. I'm like, how did that end up there?
That came up there, and I was like, oh, I've got to know what that is if I'm gonna, do this recording here. I've got to spend the time. But it's cool, because then you go on that little tangent, and then you find the people who have gone before you and wrote a blog post about it. So there's the spec, but then there's people writing blog posts about how they understood the spec, because it's a lot to kind of shove in your brain, all this stuff. So the OCI is the Open Container Initiative, I believe is the acronym. And so that's what a lot of the registries, almost all the registry now, used as a way to kind of standardize container images. Way more than I ever knew before. I've been using images, and I've been using containers, I don't know, 5+ years, and I've never cared how they were created, so to speak, but now I do. So we have, back to the demo script, we've signed the voting app, and now I'm going to sign the Postgres image, because of the control policy that we put on Ratify is, I don't care if you didn't patch it or whatever, all signatures, all container images running in the default namespace need to have a signature, or I'm gonna deny them. So we're gonna assign that as well, and that would do the same thing. It puts that nice little artifact. And what I'm gonna do is deploy my existing manifests right now. And I'm saying manifests. Sometimes I say manuscripts because I write a lot of stuff. And Steven likes to call me out on that. But if we look at these deployments, so we'll open that, we'll open this. I'm not using the signed image. I'm not even using the one that's in the registry. And I could update that, but I'd have the same result. And it's saying that it cannot, the subject failed verification. And so that's Ratify rejecting those deployments on the cluster. But it allowed us to create the other stuff that was in here. There's a service and an ingress that was able to be created. So we'll close those and bring this up and move on.
So it didn't even attempt to pull the container. Like as soon as it saw the manifest, it was like,
yep. So Ratify looks at where it's going. It kind of intercepts that and says, I can't validate the signature. It doesn't. It failed it. So no dice.
Yeah.
And so if it was successful, we should see a /verified in this log, and we only see the mutating, which is it's trying to resolve the image signature. And again, that was some, way more kubectl food than I do, but just getting the logs from the Ratify deployment in the Gatekeeper namespace, and then I'm just grepping foreboding because it also tries to pull all the other images. And there's some noise in there sometimes, but they're working on it. But anyway, if we go now, I'm using some fancy sed commands here to replace the image name with the digest. And so we'll use code to open that up. And we'll scroll down, and now we can see we've got the registry in here, and we're using the digest SHA. So the digest right there. And we'll do the same thing for the deployment. And
now I missed it. Did the Postgres deployment also fail?
Yes, it rejected both deployments, the DB and the other one. And I want to just check kubectl. Sure. Okay, good.
Cool.
Killed. And so if we look at the database, we should see the same thing. I could go to the registry and copy and paste, but probably one of my favorite things for AI to do is to generate regex and sed stuff. I don't know. It's it's a little mental puzzle that I don't enjoy. So now that we've updated that, let's try to redeploy. And it didn't
looks like
reject anything.
No?
Yep, it did. So
created, yeah.
Well, actually, I think I have commands in demo to show that. So I'm going to sleep a little bit, let the pods deploy. And this is where it was failing yesterday, so fingers crossed. Fingers crossed.
Drum roll, please. Hey, there we go. Nice.
And just for fun, what was happening yesterday was there was a change in the signature. So one thing that's important to know if we open up the main is it's very important how your certificate is created. And so if we scroll down to this section here in the Terraform where it's creating, I was getting an error because I had a certificate property that was using, I forget the acronym, but I wasn't using the PEM file. I was doing a different content type for the certificate.
It was a PFX file, right?
Yeah. Yeah, it was. And so it wasn't able to, there's a limitation actually in the Golang library that it won't be able to follow the certificate chain if you don't use exportable keys, which you shouldn't do. That's one thing they call it here is set exportable to false. Because if you don't, when Ratify goes and gets a certificate, the private key is going to be exposed in the resolution of that cert chain. But if you set certificate, the export to false, it will only get the public key. from that. So that's something to be aware of. Definitely the content type needs to be important here. And then the subject, you actually need to fill out more than CN. You need O and L and I think C. Otherwise, Ratify says you don't have enough subject information to do any verification. So make sure you put that in. I've always just done CN because that's the minimum necessary to create a certificate. But you need more than that. So there you have it.
This is actually pretty good. It's like a playbook for creating certificates for this stuff. So
lots of trial and error, like I said.
Yeah.
Let's see here. So we've got the app running. And so we looked at this earlier, but just as a review, here's the constraint. So I'm saying anything that is a deployment type, I want you to check the container images in that deployment type in the default namespace. I want you to verify them. And how that's all done is inside the custom resource definition here. And down at the very bottom, it's looking at the subject. So it needs to be the validation of that certificate, and the subject needs to be valid, needs to pass this check. And if it doesn't, we're gonna deny you. So that's that. And now we can see if the app actually works. Yeah.
Hey, there we go.
Find container images.
Yeah, that's awesome. So what would you do with the unpatched image? Do you typically just throw that away, or do you?
Yeah, from what I've seen is it just is an artifact, but if there's storage requirements or anything like that, you typically just delete it. And then
I mean, you would never be able to deploy it anyways, right? With Ratify, so
right. You could use it, for dev or whatever else if there was any design stuff. Again, it really depends on how you're using these tools in your workflow. I'm putting them all in. I'm shifting left all this stuff to put it in the pipeline. If it's on the right side, then you might have, okay, well, it's fine to use the unprefixed patch stuff in our dev namespace or our dev clusters, what have you. But as soon as you go to prod, we're only gonna allow the patched to have that signature. So yeah, there's no really a lot of good guidance around that in particular. It really depends on what your life cycle is like for your application and your containers.
Yeah, maybe keep it around just to see what was in there before. I don't know, just
Yeah, you could do that. I leave it, and then I know what one's patched and not patched, and that's just what I've done in this particular instance.
I like that game over end of demo.
Yeah, I've got to do that. It's like I always hear Snake, Metal Gear Solid. Huge.
Yeah.
So that's the game over, demo over. How are we doing on time?
We are actually pretty good on time. We're at about roughly little over 15 minutes left. So
okay. Well, we can talk about go through the bonus part. So
yeah,
a lot of this is this would be painful to do every time. Really painful. So much so that probably no one would adopt all these tools if they had to run all these command line arguments as I did. So what you can do, and is documented in here. So if you go to docs bonus, and actually part of this repository as well, this is all automated with GitHub Actions. And so if you use ADO, I believe the notation one is in Works. I don't know if there's a Trivy one, but this all works in GitHub Actions. And so
I think I've used Trivy in ADO before.
Okay, so. It probably does. It's been around for a little while. It's a pretty popular tool. The other one's not so much. Ratify obviously would work wherever you're deploying to a cluster, even not on AKS.
Yeah, and I'm sorry, I know we've been saying ADO as this acronym for Azure DevOps.
DevOps, good call out. So if we look at this, since we don't have a ton of time, I probably won't go through running all these. I'll just give the rundown, and then we'll look at a build, and we'll kind of examine the workflow file.
Yeah, that sounds good.
But if you wanted to, you could fork this repository, and you could follow these steps to get it to work inside of your actual repository. Well, let's look at the workflow first, and then we'll look at the other stuff because that's more important. So we'll look at main. Make sure this all looks good. bring up the size one more, and we'll just turn down the terminal. So again, this would be a huge pain if you had to do it all manually. Luckily, we can automate all of this with GitHub Actions, and copacetic is the only one that doesn't have an official action. And I actually have to update this to include the notation official GitHub action, which was adopted with the V1 release, which is super cool. Previously, I had written one that's underneath my handle. That's in here, but we'll get it updated. Anyway, to move forward with this, we've got a build that triggers on any push to main. And how you trigger your code workflow is totally up to you. Mine's being pushed to main. So any kind of pull requests are just checked in and pushed from that way. Then I'm going to check out the code and log into Azure. I like to put all my logins up front. I could build a container first, but I want to know that my credentials are working and all that good stuff. So I'm going to log into Azure because I'm going to be pushing these to the container registry. And I just have a secret Azure credential from a service principal. How to create all of this, how to create the secret. It's all documented and scripted inside this repository. The next step is to log into the container registry. So log into Azure, but then we also have to log into the registry itself for the runner that is executing these builds. Next, there's a build and push task that you can run. And I'm giving it a context of local, or the relative path here, because my Docker file is in the root of this repository. And check-in pulls the code down and puts it on the runner. I want it to push, not just build locally. So it's going to push up to the remote registry, and that's identified with the tag, including the ACR name. So you can see that there's some vars here. These are GitHub variable secrets that are being used inside this workflow. And then instead of creating my own tag, I'm just using the GitHub SHA as a way to uniquely identify a tag per run.
Yeah, that's super handy right there.
And yeah, for the patch, I'm just appending a -1, so at least the SHAs match per build. Trivy has a really nice action, super simple. Essentially every single parameter that the command line has, the action has too. So I'm putting in the image that I'm referencing, which is the one that I just pushed up there with the SHA. And I'm telling it sorry, my hovering keeps popping up there. The format JSON, it's going to be patch JSON. That's important because that needs to be static and correlated with the copacetic syntax. I'm only going to care about the OS vulnerabilities. I don't want to exit on or throw any error ever because I want copacetic to have a chance to go. And then I only want to care about critical. Copacetic doesn't have an action, but you can run pretty much anything with the bash runner. So I have a little download function that downloads it and build kit. They are working on removing that dependency or changing how that is, so you don't have to download that. But I'm downloading it, pushing the build kit to the bin, and starting it up in the background, and then running copacetic on the image. And you can see if I scroll over here, I'm doing that -1. I do have an open issue to put that as a build counter. So to use another action that creates an automatic increment whenever it's the same SHA. So I'll have to figure out how to put that logic in there. And then it pushes it. So I'm going to push it up there, and I'm going to grab, this is the most secure way to do it. So I was using the Docker inspect command before in the demo, but the best way to do it is to grab it from the push command. So anytime you do a push or a build, anytime that there's a new layer added, it actually outputs the digest in that stream. And that is the most secure way to get it, because then you know that there's been no tampering and modifying of that digest between the point that it was built and pushed and that layer was added to the time that you're grabbing the digest information. And so I'm just grabbing that out with some super awesome grep logic and pushing that to a GitHub variable in the workflow. That way I can use it with notation. So this will be updated. This is still on my GitHub repository, but all this logic has been moved and updated into an official one. It's called notation-action now instead of setup notation. But it's essentially the same thing. It's just installing notation on the runner for you, and then giving you these parameters to be able to plug in. So that way you don't have to do what I did above with copacetic, where you're running a bash script. It's an official, supported plugin or action. And so I want the version of notation that I'm going to use. The name of the certificate is important. I need to have that to add the cert. I need to have the key ID and then the plugin that I'm going to be using in the version of that plugin, which in my case is the Azure Key Vault. And then I sign it. And that's where I end the workflow. I could add another chained workflow that goes and deploys it to the cluster. And I did have that for my build talk, which we can put a link down here too if you want to see this all end-to-end deploying to the cluster. But that's how we can automate it. So now I put in all this legwork. I put all this effort into securing my container deployments. The beauty of it is now with automation and workflows and these CI/CD pipelines, I don't have to care about it anymore, only when it breaks. And so that's kind of the beauty of all of it, is you can learn it, put in the effort, and then you can kind of just forget about it, and you're left in a way better posture security-wise. And what this would all look like if we had more time, we can find a green build.
They're all green, right, Josh?
Yeah, I delete most of my red, so it looks better. So there's what I updated this morning, but the let's do it live, and I obviously had some issues with my escaping characters. And then, it's all the same, and then this pushes it to
8 minutes. That's not terrible.
No, it's not too bad.
Yeah.
My Go application will build faster.
I bet you the chunk of the time was in the Rust application build.
It totally is. Yeah. But yeah, anyway, that would push more to the images and all that good stuff. But yeah, that's everything that I've got in this repository. Again, you can come in here, you can star it, look at all this. All of the docs are here for every single step, from setting up the environment, to running through the workshop, to deploying it with GitHub Actions. The dev container has all the stuff that you need, even the plugins, the extensions in VS Code that you need to do the workshop. So it is all right here for you to follow along and do it at your own pace.
Yeah. You want to show them how to open it in Codespaces? It's literally you just have to click on something else. Yeah, just there you go. So just to call out there, when you click the code button, typically if you don't open Codespaces all the time, you'll be on the local tab. Yeah. So you just have to click over to that Codespaces tab.
Yeah. Then you don't even need to clone the repo down. So.
Yeah, exactly. Yeah. Well, cool, Josh. This is pretty awesome stuff. And I really love the fact that although learning all the steps and all the tooling and how to use that tooling is like a necessary evil, I love the fact that you can just write that automation script and just kind of forget about it at that point.
Yeah, my hope is a lot of people, they come in here to the workflow and they reference this and they grab it and they plug in their workflows. I wanted to go a little bit deeper into each of these tools. That way people are just more familiar with the things that they're taking out of here and pulling into the repositories and securing the code. But I think, cool. One last call out is, aside from this GitHub repository, a lot of the other stuff that people can follow us and find us are, but I'm going to call it Twitter until they change the domain name. So my handle is @JoshDuffney. And then you can follow me there. I post about the stuff that I'm doing here. Also, I like to read, and so I post about, the books that I'm reading and the projects I'm working on. And that's a great way to get a hold of me and contact me if there's anything in here you have more questions with or whatnot. But where could people reach you, Paul?
I think I put it in my name down below. It should be there, @paul.u. So you can find me on Twitter or even LinkedIn as well. So
Or
I'll
X,
be there.
As they call it.
X, yeah. I still can't get used to that.
Not me either.
Yeah. Cool. Well, this is very fun, Josh, and I'm gonna have to play with this myself. And now that Notary is v1.0, I think I put it in a tweet now I have no excuse. I just have to sign everything now.
Yep. Yeah.
It should just be a part of the workflow. Yeah. Cool. Let's see. I didn't see a whole lot of stuff in the chat. So, but if anybody has any questions, feel free to just plug them in. I know we have just a few minutes left. And if we don't have any questions in the next minute or two, then maybe we can just call it.
Yeah.
But this has been fun. Actually, this is week 3 of our summer series, and I know it's not summer for everybody. Like we have colleagues that are in Australia. Yeah. They're like, wait a minute, it's not summer. It's winter for us. But anyhow, it's been an exciting 3 weeks. It all started with Sophia and Carrie showing us how to use container apps, and then we moved on to Azure Kubernetes Service, and now Josh with this and securing the supply chain. Hopefully, folks are comfortable with container technologies on Azure. If you missed any of the sessions, I believe the RSVP, the AKS / I forgot what the AKA MS link was, but there you go. Somebody's on it. But that link there will take you to all of the previous sessions. So they're all recorded. The labs that we presented to you, they're all publicly available. And so, yeah, I would say go and try the stuff out. If you do try it out, let us know. Let us know how it worked out for you. If there's anything that needs to be improved or fixed, we'd love to hear that too. So,
absolutely.
Yeah. So with that, I think we'll call it. This has been fun, Josh.
Well, thanks for being my wingman. Appreciate it.
Yeah, no problem. We got to do this more often. So
for sure.